let's do this. So we've got the.
People can do that.
We've got properties. And we're going to go through and we're going to prove some properties. Red marker's on its way out.
You can see yourself.
U dot V equals V dot U. It is commutative. Is that obvious?
Yeah, pretty.
Should we prove it?
No.
Can you prove it on a quiz next Tuesday?
No.
Yeah.
It's multiplication. So this would be AB plus CD. Oh, depending on it, equals BA plus DC if U is AC and V is BD. So that's the same as that. Because multiplication is commutative. Should we prove it? Hey, there's the proof. We're already done. That is your proof. That is a proof. How about if we do 0, the 0 vector, dotted with V? Zero vector dot V. What are we gonna get?
0.
That would make sense, wouldn't it?
It's not gonna. It's gonna be like
Oh no, it'll
negative
equal
1.
V. It'll equal V, right?
The 0 vector is going to be 0, 0. We move 0 in the horizontal, 0 in the vertical. Dot V. So I'm just going to use AB. So if we do 0, 0 dot AB, what are we going to get? 0A plus 0B, and what's that?
0.
All right, the whole thing's 0.
Wait.
I said, does that make sense? And everybody automatically jumped to no because I was asking about it. Because 1 plus 2 plus 3 plus 4 gets you 112. Good.
It's not. No, it's not. It's like no. It's like
Early dismissal.
Yeah, but it looks terrible outside. We should probably go home. It looks dangerous.
U dot V plus W. What do we get if we add two vectors? That's the third vector. W is a third vector. If we take a vector and we add a vector, what do we get? You get a vector. We have a vector dotted with a vector. We're going to get UV, U dot V, plus U dot W.
So is it like distributive?
This is the distributive property. Distributes over vector addition. How about if I take three vectors, U gonna be AB, V shall be CD, and W shall be EF. What do we get if we do U dot V dot W?
It's like you also do U dot V first and then do W.
If we do this, these two first, this is just gonna be a number. That's just a scalar.
And then you multiply that.
That's a vector.
So would it be ACE
plus y, 1y, 2y,
Would it be
ACE
no?
plus TDF?
It doesn't
You
work.
cannot dot a scalar with a vector.
No?
You cannot dot a scalar with a vector. You cannot cross a scalar with a vector in terms of the other product. W's got an extra little hump to it. Cross product? No. You can't cross a vector with a scalar either. So we can have scalar multiplication before we had scalar multiplication. Before, like if we have C times AB, it is CA, CB. That's scalar multiplication. We're just increasing the length of our vector in each of those directions. So what we have here, you can't use the dot product. The dot product does not exist between a scalar and a vector. So this is scalar multiplication, this is dot product.
In that case, why is W a vector?
It doesn't make sense in this case. What I was trying to show you back here is that if we have three vectors and we're trying to dot three vectors, we can't do that. There is no associative property with vectors. So this does not work. So it doesn't work. It doesn't make sense. So W couldn't be a vector if we wanted to try
In
that.
that case, though, was W a vector just because you said it was?
It's a vector because I said it was right here. I've got a horizontal and a vertical
Because I
component.
said so.
I've got a horizontal and vertical. I'm saying U is a vector, V is a vector, W is a vector.
Oh, okay.
I wanted to see what you said with three vectors being dotted. Can't do it. Sure. The other thing, you cannot, there is no dot product between a scalar and a vector. You can only find the dot product between two vectors. Only find the dot product between two vectors.
Like an even number?
You can only find a...
Or could you do?
We could do the dot product between the first two, the dot product between the second two, and then multiply the two numbers.
But you couldn't find the dot product in two scalars.
But we couldn't do, there's no dot product between two scalars. We could not do the dot product between the middle two and then dot it with the first vector, dot it with the last vector.
You could or
Couldn't. Doesn't,
So if there were three, do you do the dot product of the first two?
you just can't do it.
So then will you only do like
You just can't do it. You just cannot do this.
If you see that, there's no solution.
You see this? It's nonsense. It's like taking 3 divided by square root. What if I give you 3 divided by square root?
No.
That's nonsense. How about if we do 4 plus turtle? No, that would be 4 times turtle. That's multiplication, scalar multiplication. But if we do 4, it doesn't make sense. So you can't do that. Okay.
Wait, you should really draw it in motion form. So
Yeah, just like
Yeah, please.
you have to draw some water.
We can't just leave them hanging like that.
That's a tortoise instead. It's 4 plus tortoise now.
No, you can't.
No, you can't. You draw.
They're different.
Give him a friend. He sounded so offended.
There's a pond. He's headed to the pond.
Are there other
Cattails or details?
Draw one. That looks like an ice skate.
Turtles get ice skate.
Don't take brother.
Let's take our 2 vectors. We don't want to do that. That's too easy. Let's say our vector is 3, 4, and vector u is -5, 12. I shouldn't have made it 12.
Make it,
Make it like 7.
make it 7.
It's not too late.
It's 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So we have 1, 2, 3, 1, 2, 3, 4. One, 2, 3, 4, 5, 6. So I've got V, I've got U. What's the angle between those two? 75 degrees. All right, moving on. How did you get 75?
I was thinking of Vince Wilfork.
I don't know what that means.
Number 75.
Okay.
And I was thinking about his big wide pizza. And
Okay.
I was thinking about food.
You and pizza. You
No, I know the actual measurement.
you know the actual measurement. Okay.
It's 90 degrees.
No, it's not.
Because look, if you point, if you extend V to the third quadrant and then V to the fourth, it divides the whole coordinate plane into 4 pieces, and then 360 divided by 4.
Rule number 7, don't trust my drawings. Rule number 7, don't trust my drawings.
What are like the
We
first
have to use
6?
the numbers.
Rule number 1 is don't trust me.
Do you have to do
That's
like
true,
the
because you like
before,
this.
like
I don't remember.
10?
Here's what's going to go on. This is, let's think about this for a moment. V is our, if I know the angle for V, and I know the angle for U, I'm going to use theta and phi. Actually, let's use something not theta, because we've already got theta in there. Alpha. So if V is a vector at angle alpha, and U is a vector at angle phi, how would I get angle theta in there? How would I get the difference between the two?
180 minus 8
Or I could just do this angle minus this angle. So that angle between them is going to be the bigger angle minus the smaller angle. So this angle here, let's draw this out. This is alpha. This one all the way over here is phi.
Wait,
All-
from
From the origin, from the x-axis. So if I want the angle between the two,
Oh, then I get it. Oh.
Is it?
so if phi is the entire angle, and alpha is the smaller angle, and I want the angle between the two of them,
But do you know those?
I don't know those.
So then how do you know? So then you still don't know.
Well, you have the size.
We have 3, 4, 5, 9.
We can find
Let's look at this. Let's look at this. V has a magnitude. I'm leading you through a long way. V has a magnitude. What is the magnitude of vector V? So V is actually 5 at, what was it? Alpha. What's the magnitude of U? Root 51. So U is really root 51 at phi, and I want the angle between the two of them. If we have magnitude and angle, if we have magnitude and direction, how do we actually take? How do we take our magnitude and direction and find the components? Do we remember how to take magnitude and direction and get the components? So when we have some vector, I'm going to use W. That's going to be the magnitude of W, cosine of the angle, right? It's going to be magnitude of W, sine of the angle. So keep in mind, this 3, 4, this negative 5, 6, that is these parts. Now, we could take these and yes, 3, 4, negative 5, 6, we could find the angles. I'm going to hold back right now because I want to show you something else. If we take two vectors, I'll put this on the side. Put that on the side. Let's say we have a cosine theta, a sine theta is our first vector, and we have b cosine phi, b sine phi is our second vector. What do we get when we dot those two together? We're going to get these two multiplied. We're going to get a, b, cosine theta, cosine phi. This times this, dot product, plus this times this. We're going to have a, b, sine theta, sine phi. It's like a circle with a line vertically.
That's just completely different.
This is the uppercase,
It looks like a Disney Y.
Yeah.
lowercase, uppercase, lowercase. So watch. I start drawing a circle, but then I go through it.
I thought the one on top was iota.
Iota,
That's just a little long.
you ready for it? Iota
5 theta.
is that one.
Oh. Oh, we did this.
Uppercase omega.
Oh yeah. Aren't you like self-conscious about your omegas?
Yeah, I don't like the way it looks out. Thanks for pointing. Look at this! Look at this! What's the same between these two?
Baby.
What if I have AB, that's going to be cosine theta, cosine phi, plus, that's going to be sine theta, sine phi. Oh! Oh! We know this thing!
We do not.
Do we really?
This is one of our trig identities.
Whoa.
They're back.
Everything's interconnected with each other.
Cosine the first, cosine the second, plus sine the first, sine the second. That is AB. That is cosine theta minus phi. That's our difference identity. That's our difference identity. Look at your identity sheets. This is your difference identity. Look at your identity sheets. That is this.
Cosine of like of two angles and the other two equals to cosine one, cosine the second one minus.
Look at your, so cosine the first, cosine the second, plus sine the first, sine the second is the difference formula for cosine.
It's like the opposite.
Cosine, see, you change the signs.
That was
So what that tells me,
Oh, do you mind? I don't think it was.
so what that tells me, where did all of this come from? That was the dot product between the two. So, if we have A dot B, that is the magnitude of A times the magnitude of B. Cosine, the difference of the angles.
That's multiplication now.
Multiplication, dot product. So, yeah, as in like the word so leading up. Or cosine of the angle between is going to be the dot product divided by the product of the magnitudes.
Wait, I don't get where you got the magnitude.
Here is AB, AB. Those are the magnitudes. Those are the magnitudes all the way up. So, magnitude, magnitude. Each time here is the magnitude.
Like, look. I don't even think there's a real one. I want to nice.
So, going back to the original, gave you this. We had two vectors. I wanted the angle between them. The angle between those two, well, cosine of that angle is going to be v dot u divided by the magnitude of v times the magnitude of u. V dot u, I'm going to do this one in my head. We've got 3 times negative 5 is negative 15, plus 4 times 6, 24. Negative 15 plus 24. Negative 15 plus 24 gets me 9. Divided by the product of the magnitudes. 5 times root 51. 5 root 51. Cosine of that angle equals 9 over 5 root 51. Or our angle between the two gets us cosine inverse of 9 over 5 root 51. And then you can plug that into the calculator and get that. We could make the triangles. There are other ways of doing it. There are other ways of doing it. This is one way. If this is 90 degrees, cosine inverse of what is going to give us 90? Well, cosine of 90 degrees is? What's the cosine of 90? Cosine of 90 is 0. So, if the dot product is 0, if the dot product is 0, then that means that the angle is 90 degrees. You got an error with this?
You have to like do it out.
Can you just tell me what that equals?
Be careful with parentheses.
It equals 75.4.
75.4. Who said 75?
I wonder.